Okay, so in this video, I'm going to explain to you how it is that you work with the chain rule numerically. We are given a table of values with several function values for f and g, but we are also given the derivative of f and g when x is 1 and 2. I want to remind you that this d dx thing means take the derivative of whatever is next to me, so it's a command. We're going to take the derivative of f of g of x. That's a composition. It's not f times g. It's g inside of f. And because it's a composition, we have to use chain rule. But this is actually easier than the algebraic way. You see, all you really have to do is take the derivative of the outside, and we're going to use notation since we don't actually know the function. The derivative of f is simply the derivative of f prime. And we're going to leave the inside alone, okay? So that's the derivative of the outside, leaving the inside alone, times the derivative of the inside, which is simply g prime, okay? And this is actually the notation that I gave you for chain rule. This is what it is. But in this case, they want us to do it for the value of 1. So instead of x, we will replace that x with a 1. And now we're going to use our table to evaluate this, okay? We're going to go inside of f prime of the f prime. It says to find g of 1. G of 1 is 2. So this expression will become f prime of 2 because g of 1 is 2. And we're going to multiply that by g prime of 1. G prime of 1 is 7. And now I will figure out the derivative of f at 2, which is 6. And so I end up with 6 times 7, which is 42. And I evaluated the derivative numerically. Okay? I'm going to explain now how to do letter C. And let me set that up. So in letter C, we want to take the derivative of f squared of x. And what that really means is that the entire function has been squared. So just like with trig, I kind of like to rewrite this as f of x, and then the whole thing has been squared. So you can now see that the inner function is f, and the outer function is squared. Here's your inner, here's your outer. So to take the derivative, we'll take the derivative of the outside. So that'll be 2, leaving the inside alone, times the derivative of the inside. And we'll just use the notation because right now we don't actually have a function to work with. And they, of course, want us to do that at 2, so I will replace these x's with 2's. And f of 2, I'm going to evaluate now. This is the derivative, I'm going to evaluate. F of 2 is 1, so this becomes 2. And don't forget, I did subtract the power, but it's just the power. 2 minus 1 is 1. So it'll be 2 times 1 times the derivative of f at 2, which is 6. And I get 2 times 1 times 6, which of course is 12. And that's it. We're done. I'm not going to go over letter E. It's a little bit of a challenge one, but I do want to give you the hint. You have a g squared, which I would rewrite as g of x all raised to the second power, but it is being multiplied by f. So I'm going to let you kind of think about what that means when you have a product. What is it that you should be doing? So I'll go ahead and let that one go for a challenge. And now that I've gone over those 2 examples, hopefully that is enough to get you through number 2 as well. Okay? Okay, so now we're going to look at the chain rule graphically. And you will notice that we were given the function f of x here and g of x here. For the purpose of this function, it's kind of hard to tell, but from -2, it's 1, 2, 3, 4, 5, It's actually up here at 6, okay? So make sure we know that point. All right, the first thing I want to make sure review from pre-calc is how to evaluate a composite function. So in number 3, we're not even taking the derivative. We're just going to evaluate h of -2. Well, h of x is right here. It's equal to the composite function f of g of x. So what they want you to do is to evaluate f of g of -2. That's really what they want you to do. And so just like you would do algebraically, you would first evaluate the inside and then use that y value to evaluate the outside. So what we're going to do is we're going to go first in here at g of -2, and make sure you go to the right graph. We're going to go to g at -2, we're going to go up to where we find the graph, and we notice that that is 1, 2, 3, 4. So the y value at -2 of g is 4. So this expression becomes f of 4. Okay, so the y value of g of -2 is now the x value of f. And at 4, 1, 2, 3, 4, that's actually a -2 where it hits. That would be -2. And that's how you evaluate a composite function. So you can go ahead and try the other 5 examples. They do them just like that. And I will set up so we can look at derivatives now. So I have here letter B says, is h prime a -1 positive, negative, or 0? And I want you to notice, first of all, they're not asking you for an actual numerical answer. They just want to know if this is going to be positive, negative, or 0. And so we're going to go ahead and start with h of x. H of x itself is defined right up here as the composite function f of g of x. Because it's a composite, if we're going to take the derivative of that, h prime of x, we must then take the derivative using chain rule, which using notation would be the derivative of the outer, that's f, leave the inside alone, times the derivative of the inside. So by now you've probably seen this, I don't know, 25 times. And that's the setup. For this problem though, they want us to insert the x value -1. So we're just going to replace x with -1, and then we're going to evaluate as best as we can. F prime g of -1. Let's go inside and find g of -1. G of -1, let's see, 1, 3, whoops, let's say that's going to be 3.5, yeah? So we are going to get f prime of 3.5 times the derivative of g at -1. Okay, so what's going to happen now is that we are going to go to f and we are going to go to g, but instead of looking at the y values, we need to look for the derivative at those spots, which means we're going to look at the slope. We're not going to look at the y values. In my first step, it was g of -1. There was no derivative, so I actually found the y value, which I'm estimating is 3.5. But, and normally you won't have to estimate. This is just an example where that happened. But when we go to do the derivative, we're no longer going to look at the y value. Instead, we need to look at the slope. So if you go to f at 3.5, we are not going to look at the y value. We are going to look at the slope of the tangent line there. And the slope of the tangent line at 3.5 is negative. So that's all I'm going to put there. This is supposed to be times. Again, this program is acting up, so I apologize. At -1 for g, if you go to g, again, you are not looking at the y value, you're looking at the slope. You're going to notice that's a negative slope as well. So we don't really need to know the actual answer. We just need to know that a negative times a negative equals a positive. Therefore, h prime of 1, it tells us to determine if it's positive, negative, or 0. Well, using the chain rule, we found it to be positive. The last thing I'm going to say before closing this out is that the last question says k of x, and k of x, of course, is defined here as f of x to the 4th power. So keep in mind, x to the 4th power is inside of the f. So that's the inner, the outer is f. It asks you if it's increasing or decreasing at -1. It's a little bit, we haven't quite touched on this topic very deeply, but I have said before, for a function to be increasing, it must be going up, which means it has to have a positive slope, which would mean that k prime would have to be positive there. If a function is decreasing, then it's going to have a negative slope, which would mean the derivative, k prime of x, would have to be negative. So when they say increasing, decreasing, they're really just asking if the derivative is positive or negative. And because it is a composite, you're going to have to use chain rule. Derivative of the outside, leave the inside alone, times the derivative of the inside. That's a challenge one, so I'm going to let you guys think about that. Hopefully this video was enough. I apologize because my technology is just not playing nice, but hopefully it got through to you. If you have questions, comments, concerns, or just kind of want to say hi, you can text me or email me. You know where to find me. All right, guys. Hope you guys have a great weekend. It's good to be back, and we'll see you soon.